first thing we need to understand is to answer the question of why do I need a data warehouse, is that our customer is different from an application. In an application, you have whoever is entering the data in the system. And to go back to my healthcare examples, if you're entering data into an electronic medical record system, your users are your nurses, your doctors, your receptionists. But the data warehouse is more a company level thing. You're looking at your managers and business analysts who are trying to look at the performance of the entire company. So we have so much data in so many different systems, but they have problems finding the data they need. It's scattered among a lot of different systems, and even within an application, you might have different versions or formats. So even if they know where the data is, they can't get the data they need. So they can't directly access it. They need to go and find a technical expert who can pull the data out for them. Once they get the data, they may not understand it. It's often very cryptic how it is. It's often not well documented, so it's hard to understand. And then once they get all their data, they got data from multiple systems, they can't really use it because the data doesn't necessarily map together. So they're having to take it and pull it into spreadsheets and munge the data a little bit to get something they can do reporting on. So doing a company level reporting on their business is very difficult. And this is where the data warehouse can help them out. So here's an example of what I was just talking about. You have your applications that typically have, your transactional databases, and these are what are used to run the business. While your data warehouse is being used by the managers and it's used to optimize the business. So in this example, we have an electronic medical record system where you have your nurses and doctors entering data into it. You have a lab system where your lab technicians are entering your lab results. You have a PACS system where the people who are taking your MRIs and X-rays are entering the images in, the radiologists are putting their results in it. And you have a lot of other systems that are feeding this in as well. But in order to take a full look at how the enterprise is doing, these need to be conformed into a single source and made easily accessed by the manager, and that's what the data warehouse does. So let's do a little comparison about the transactional database and a data warehouse. So the transactional database is going to be application-oriented, specific to an application, while the data warehouse is subject-oriented. So once again, application-oriented is an electronic medical record system, while subject-oriented is the healthcare. The transactional database is used to run the business as opposed to the data warehouse where it's used to analyze the business. In transactional databases, you have detailed real-time information that is isolated to that system. In the data warehouse, you have summarized, refined data. It's typically a snapshot of a moment in time, and it's integrated with multiple systems. You have both read and write access to the transactional database, but a data warehouse is really meant for only read-only. In the transactional database, you have many users who are accessing one or a few records at a time, while in the data warehouse, you have a few users, typically management, who are accessing very large volumes of data at a time. The performance metric for a transactional database is transaction throughput. And in order to achieve this, you typically have a normalized database where you're looking to minimize data redundancy. In a data warehouse, the performance metric is query throughput, in which case we're not going to have normalized data. We don't care about data redundancy. We want to minimize joins so your queries are going to be as quick as possible. So to summarize this, a data warehouse is a copy of transactional data, typically from multiple sources, transformed into a common format and structured to optimize querying and reporting. It provides a customer-centric view of the company's data, and it will integrate data from various departments and systems, so it provides a look at activities at cross-functional lines. And this is a means of reporting on trends across multi-divisional and possibly multinational operating units. So the data modeling for the two type of databases varies significantly. In a transactional, in your application type stuff, you're doing entity relationship modeling, versus in a data warehouse, you're doing dimensional modeling. So in the ER modeling, you're going to be focused more on the data. So for a given data item, You're going to show how it relates to things for all the business processes in the enterprise. So for instance, if you're seeking to reduce data redundancy, so if you have an employee and a patient and a doctor, you're going to say, well, these are all different types of persons. So I'm going to have a person table that abstracts out all the common things so I don't have data redundancy. And then I will have the other tables just to do the specifics to them. In a data warehouse, we're focusing on just one specific process. So while you might have just one big entity relationship model in the transactional database, in the dimensional model, I'm going to have multiple models, one for each business process. And in this case, I don't care about the data redundancy, so I don't care about having a generalized person table. What I want is to minimize joins, so if my dimensional model is connecting to a doctor table, I want all of the information about that doctor in just that one table, so I don't have to do a join to an address table, and to a person table, and to all the different tables. The whole idea is to minimize these joins. So besides making queries more efficient, these dimensional models are also more intuitive to business users who need to query the data. The one thing I can't stress enough is it is about the business. This is all about making sure that we understand the business processes and making something that's usable for the end user, who once again is a manager of the business. So understanding the core business processes is essential to creating a dimensional model. And that means you need to have involvement from the right people. So you need the right business representatives representing both cross-management, vertical ranks, and horizontal, so cross-department ranks. And you need to have an experienced requirements analyst who knows how to work with these business representatives and who knows how to ask, what do you do, not what do you want? So the dimensional model should always be matching what the subject matter is, not the system you're copying from, especially since you can be bringing data from multiple types of systems. So let me give you a little bit of the terminology of data warehouse, which we'll get into a little bit later. So once again, remember that each of these models is focused on a single business process, and I'll give you some examples later. But so each one has what is called a star schema that represents it. And star schema just means it's a very simple layout. You have what's called a fact table in the middle and multiple dimensions around it. So it looks like a star. Once again, the idea is minimum joins. It's very simple. So the fact table is the table that is going to represent that business process. And it consists of the measurements, metrics, or facts that are associated with that process. For instance, if I'm doing a business process that is looking at ER visits, I might have facts in there that say, what was the time between registration of the patient and admission into the ER? What was the length of time between the admission and the discharge? What was the reason for discharge? Were they admitted to a hospital, or were they just discharged? What was the reason for them coming in? What was the procedures that were done on them? These are all facts. Now the dimensions are the reference data that hang around the facts. So these are going to say, what nurse dealt with this patient while they were in the visit? What was the date and time of the visit? Who was the doctor? What diagnoses were attached to it? What services were performed? All of this is the dimensional model, and these are designed in such a way where inside each dimension, it gives you all the information you need from a reporting point of view to slice and dice the data. All the things that, possible filters, all the values you might need in it, column names that would appear in reports, things like that. So when you are defining a star schema for a particular process, you need to define the grain. The grain is defining the finest level of detail implied by that fact and dimension table joined together. So in the case of the ER visit, the grain of it is a particular visit to the ER by a patient. So the first step in coming up with your data warehouse is to define what your processes are. And the tool that is typically used is called the bus matrix. And this is a step that just really, you can't scrimp on. You need to spend the time to figure this out, because this is setting you up for everything you're going to be doing moving forward. And if you don't get this right, you're going to be building the wrong thing. So the bus matrix is a business process matrix, and it's a collaboration tool used to develop an understanding of the business's needs. So each column of it is going to represent a natural grouping of standardized descriptive reference data. So this becomes your dimensions. Each row represents a core business process. Now, I'm going to show you an example of this, and one of the things you'll see is that makes this invaluable as well is it also becomes a good blueprint to come up with an incremental development plan. So this is a business process matrix I came up with for one customer. And as you can see, I have the list of business processes defined for each row. So this particular example is for a home health care company. And what I did is I sat down with them and tried to understand all the processes they're going through. So they explained to me how, first they get a patient referral. And so a patient gets referred. That referral is going to result in either a decision not to be taken into care or into an admission. So that is one process. And then the next one is an admission of a patient. So the admission is going to be the patient's been admitted to care. An admission event is going to go until discharge. You can also go to more detailed processes. So within an admission, there are different episodes of care. So the patient was admitted, and then they got sent to the hospital, which ends an episode of care. Once the patient returns from the hospital, they resume care until they're discharged. So those are two different episodes of care. So that's drilling down. And here I drill down again into the visits because you have a home health worker who's going in and visiting the patient on a daily basis. So that's another level. So these are my business processes that I'm trying to capture. Now I'm going to identify the dimensions for each of these. So for a given process, this first process being the referral, there's a date and time associated with it. There's a patient associated with it. There's a caregiver who participated and a doctor. There are services that are performed like physical therapy versus occupational therapy. There's a payer contract, so the insurance company that's associated with it. We go through and we identify all the different reference data that defines these processes. Now, I usually add a few other columns to my table just to make it more of a working tool. And in particular, I have this where I go into a little more detail of the process description, and that's something that helps me understand, make sure I'm on the same page with the client. And then I put in a final column that is the performance metrics, which is not all inclusive, but for instance, in this case in the referral, it says these are reports that the client is trying to get out of it. One of the questions they want answered is what percentage of referrals result in admissions. My goal when I'm making this data warehouse is that they're going to be able to come up with reports they haven't even thought of yet. But it's useful for me to know what reports they already have thought of. It helps give me a direction that I'm going. So once I have this business process matrix, you don't want to just dive in and try to build a whole data warehouse at once. So it lends itself really easily to incremental development. So I typically take one process in the business matrix, and I do that as my first increment. The other thing is the data warehouse is taking data from multiple sources, but for my first increment, I'm only going to choose a single source to take it from and probably a limited time frame. But for each of my increments, I'm going to do full slice development. I'm going to extract the data from the source data. I'm going to get it transformed and loaded in the data warehouse. I'm going to test it. I'm going to actually generate the end reports to see that I can do the type of reporting that they're interested in, and then review that with the client and refine the dimensional model before I move on. Now, in the details of that, what I'll typically do, particularly in my first slice, is I do just some prototyping first, where I just run some sample queries. Can I pull the data from the tables, my source tables, and write them into these data warehouse tables that I've created? So I do the simple extract, I review it with the client, make sure we have what we look. At that point, once I know what I'm doing, I actually do the ETL process. And ETL stands for extract, transform, and load, and it's a typical data warehousing process. So first you're extracting the data from the source system into staging tables. Then you transform that data as needed to conform the dimensions. So I might have source systems where, let's use for example, doctors. One of the jobs I work on, we have Skagit Valley Hospital has a group of doctors, and Island Hospital has a group of doctors, and some of the doctors are in both hospitals. So you have different codes in Skagit that represent the doctors than you do in Island. So I have to have mapping tables because what I need to have in my data warehouse is just a single set of doctors with a single code representing them, a master file. And so I'm going to do mapping from the various systems to it. My transformation is when I'm conforming those dimensions so that I'm mapping it to a single master set of files. And once I've done this extraction and transformation, then I'm going to actually load it into the data warehouse tables. So I am going to show you an example of one of the data warehouses I've been working on. So I am working for a company that does home health care. And they have multiple sites or customers that they support. And each site has an application with its own database. And in the case where we started working with them, this was a Synergex application. And then to add a little complexity to it, all of them were different versions of the system. They all had their unique code. They've recently moved away from their Synergex system and purchased a new system. So I have all of these Synergex systems that used to be their system they were using on that has the legacy data, each with a different version of it. And they've all purchased this new module that they want to have an integrated view of all of this. So they need a data warehouse so that they can see things across sites and across applications. Now, in the case of healthcare, sometimes you're not even getting things just from a database. Sometimes you're getting things like HL7 messages, which is the standardized protocol for transferring data between healthcare systems. And when you're doing data warehousing, you can just receive these type of messages yourself, get those written to staging tables, and that can just be another source of data. Other sources that you might see are some of the dimensional data, maybe is something the customer updates annually. For instance, on this home health care one, they have the list of services that they provide, so physical therapy, occupational therapy, speech therapy, skilled nursing, and they have a cost of each of those services because one of the measurements they want is how much did this episode cost us. And that cost is going to vary year from year. So every year they need to give me a new set of costs, and I load that into the data warehouse so that I can do the calculations. Then one of the things you can also do is in the process of doing the extraction, transforming, and loading, you may find dirty data. Depending on the system, there's some places I've found where you don't see much of it. There are some systems where there is so much dirty data, and you can't have the dirty data in the data warehouse because garbage in and garbage out. So what I do is I do certain validation as part of that transformation process, and I write the ones that don't match those validation rules. I'm rejecting them. I write them to a spreadsheet. I have an automatic report that's generated, sent back to the client. They can make corrections, and then I can suck that back in and apply those corrections and reprocess them. So this is just kind of laying out the example I'm going to show you. So I already showed you the business process matrix for that particular one, but here's a system diagram for it. So my sources of data, I have the legacy files, the ISAM files from the legacy system. I have the new system, which has a Sybase database. I have some spreadsheets where the customer is giving me the information like how much each service costs. I also get some HL7 messages in that are being processed through an interface engine. So these are all getting sent over to my staging area. So in the case of the ISAM files, we have the replicated legacy data, which is just like Steve was showing us. We got that replicated over there into some SQL tables now. I've processed the spreadsheets into some more staging tables. The HL7 messages, my interface engine is writing those right to another staging table. And I take all that data and I run it through my process where I identify the various visits and I write those to the data warehouse. Now, any of the visits that are rejected, those are getting sent out to that error spreadsheet where the user will update it, apply their corrections. I suck that into the staging tables and then reprocess everything. And the end result is this data warehouse. So here's an example of this one-star schema. And you saw on my business matrix, I had, about 8 rows? So this is representing 1 row. So this is an episode of care which goes from when a patient is admitted until they leave care, either because they're hospitalized or they've been discharged. And that is called an episode of care. And most of my facts, so my fact table is in the middle. This is the table that contains all the measurements. Most of the things in the fact table are just foreign keys out to my dimensions, which are around the edge. But I also have some measurements in there. So I have measurements like, what is the episode duration? What is the estimated cost of the episode? The HERG score is something used by Medicare to see. It's a score that drives their reimbursements. The rest of these are just keys to my dimensions. So I have a dimension for date and time, for the nurse, the doctor, the insurance contract, the episode type, and the patient. I also have dimensions for diagnosis and services, but in the case of these, since a patient can have multiple diagnoses or multiple services performed, I use bridge tables to handle the many-to-many relationship. But the key to designing these dimensions is to think in terms of the reporting that's going to be done later. The name of the columns is very important because in our applications, quite often our data names are rather obscure and only the developers know what they mean. In a data warehouse, these are the names that are actually going to be pulled into the report. So you need to be working with the client to make sure that these are business names that make sense to them. So the dimension should have everything it needs in order to slice and dice these. If they're in the report and they want to filter on something or they want to group things together or do anything like this, all the data to do that filtering or grouping should be in this dimension. For example, the dim date, the dimension for date, you would think that, why do you need a dimension just for date? Well, our date dimension has one row in it for every possible date range you're going to have. And in that, you can get just the year. One of the columns is, what is just the year? What is the month? What is the day of the week? So it has all these different things that anyone might ever want to query on. Like they might want to say, for ER visits, I want to know, do we have more ER visits on Fridays than on Mondays? Well, because the date dimension has day of the week in it, that's easy for them to do. We don't have to write a special query. The ETL process, this is our extract, transform, and load. In this example, I use SQL Server Integration Services to do it. And I'm not going to go into detail of this. I'm just trying to show you an example of how it processes. So you have some source you pull the data from, and you can do certain conversions on it, and you can do logic to branch or anything. You look at certain values, you branch, you decide which way to go. You can update data, both in the staging area and in the data warehouse. And as far as the source goes, the sources can be, I have some where I'm not even using staging tables. For instance, I'm going out and directly accessing that Sybase database, or it might be a staging table on my same server that I'm accessing. But I can keep counts, I can run metrics on it, and it's just basically code that goes through and steps through, does all the validation you want to do, validate the data, write out to an error spreadsheet if it's wrong, and the end result is to write things out to the data warehouse. So the final step of the process is your reporting. And our goal with this is to let the end user do the majority of the reporting themselves. Now, once again, there is some reporting that, for instance, on my error spreadsheet, that I'll use something like SQL Server Reporting Services to generate a report automatically and have it sent to the customer to make the corrections on. But the actual business reports, the goal is to put that in the hands of the end user. Let the manager run the reports themselves. And there are excellent business intelligence tools out there that those end users can use on their own in order to do this. So it kind of gets the developers out of the loop. The goal is to get all the data in the data warehouse that they might ever want to query on, and then let them decide what reports they want to do. So this is back on the example from the home healthcare one, and this is a tool called Tableau that is available to use. So in this case, they wanted to know, they were looking at hospital admission rates. One of the things they're dinged on by Medicare is if the patient has to go to the hospital, they get brought back into care, and then they have another hospital admission within 30 days. Because if they do that, Medicare says you're not doing a good enough job of taking care of this patient, so your reimbursement rates are going to go down. So they want to figure out ways to minimize hospital readmissions. One of the questions that they thought would be interesting to ask is, we have a lot of patients who English is not their first language. So how big of a difference does it make if the clinician can speak the same language as the patient? So here they were able to just drag over, if you look up at the columns at the top, they just drag what they're going to have in the columns. They have on the left, they have the list of all the different fields they have. They can create their own calculated fields, do counts on things or any type of calculations, and then they indicate what their rows are going to be and they choose their report type. So in this one, this was showing what the hospital rate was based on when there was a language match between the patient and clinician versus when there wasn't. So here's another report that they did. They liked to see how many episodes occurred for a given type of diagnosis. So this way they can go through and measure what their most frequent diagnoses are. That can help them with their staffing decisions and try and figure out how to best meet the needs of things. This one's an interesting one. Some of these tools, they do some very cool things. So this is a geographic one that says the number of episodes by zip code. So this is of the Boston area, and they wanted to see where their busiest areas were. And so they can go in and drill down into them as well. So to summarize, data warehousing is a process of transforming data into information and making it available to users in a timely enough manner to make a difference. So once you've created your data warehouse, you can use intuitive BI reporting tools to allow users to generate their own reports on the fly and allow businesses a level of insight that helps them take their business to the next level. Are there any questions?
I'm interested in this concept of the grain. I mean, how low does that go? How small does that go to be considered a grain?
Well, you can take it to various levels. But the important thing of the grain is just to make sure you understand what it is so that when you design that schema, everything adheres to that grain. You know, if you start mixing, it's kind of a test for you to always say, is my dimensional model right? Because does it match this grain? But an example I showed you, I had some at different levels. So for instance, an admission event. A patient maybe have been admitted into care in 2011 and is still under care. That's one big admission event. But perhaps every 2 months they get sent to the hospital. So there's all these different episodes of care within that admission event. So now our grain has now gone lower to where we have one dimensional model for an admission. We have another dimensional model for the episode of care. Now within an episode of care, you have encounters with the patient. That's when a skilled nurse goes to meet with the patient or a physical therapist goes. Each of those are a different encounter or visit. That's my third, more detailed. So my grains, I have dimensional models for all three of these levels, and each one is more detailed.
I was just asking what different tools have you been using? You showed Tableau. What other ones, and SQL Server reporting services for reports? Have you done anything with Power BI as an alternative? I
have not. I've looked a little bit into it, but the only ones I have experience with myself is SQL Server reporting services and Tableau. But I'm not really, in the data warehouse I've done, the reporting side hasn't been my specialty so much. And there are so many different data warehousing tools out there. I personally have experience just with one slice of it. We've stayed mostly on the Microsoft platform, so SQL Server integration services, SQL Server reporting services, and then on the reporting side, our clients tend to do that. And I've played around enough with Tableau that I can generate some reports, but it's not my specialty.
My question is around using views to sort of look at the data and make it easier for reporting versus creating a totally different schema. So if you've got transactional data, is going to that star schema better than just creating simplified views that the users can have?
You know, if you're really only looking at one system, quite often you can just do a view to do that. Once again, the strength of the data warehouse is when you have multiple different systems, different versions, and you need to conform that data and make it where you can go cross-application. If you're really only looking at a single system on a single database, but I know like even This, when it was single system, this one customer, each of their sites had their own database, so it was still better to have the data warehouse, and a lot of it was just very cryptic, what it was, which you can solve that in the view too, you know, come up with good column names in the view. So yeah, single system view can do it for you, but when you're trying to bring it across multiple systems, that's where the data warehouse is going to be valuable for you.
Okay, thank you very much.
Thank you.